Okay, here we are. We're going to talk about congruent figures. This is 2.4. Okay, so congruent figures are figures that are equal in the angle and length of the object, but the key word here is rigid motions. Let's underline that. So everything that we have learned, translations, reflections, rotations, are all what we call rigid motions. Okay, the shape stays the same. As you can see down here, right here, you have two things, and all they've done is basically they've moved this triangle from here to here. So they still have the same angles. So they're showing you, and this is how they do it. They put this angle here is congruent to this angle here, and you can tell because this is how we show congruency, by putting a little hoop here. And this one has 2, and it corresponds with the other one that has 2. This one corresponds with that. So another key word here is corresponding angles. Okay, so rigid motions, no matter which of the 3 we do, so we can rotate, reflect, or move, basically translate, and they will still have congruent angles and congruent sides. Okay, and we show congruency of angles with the little hoopy things, like these things, right? And we actually show, they don't have this on here, but I'm going to add it. They show congruent sides by going like this and putting a line, and then this one would be 2, so it's kind of the same idea, and then this one would be 3. Another key, this triangle, we would call this triangle, that's the symbol for triangle, A, B, C. Now if I say that this is congruent, which the symbol for congruent is this, with the equal sign, little squirrely sign on top with the equal sign, then it needs to be exactly, so since this A vertice corresponds to the D, and B corresponds to E, and C corresponds to F, it has to be in that order. So we would say it corresponds, which is this thing, to D, E, F. All right, so we're going to do that now. So we're going to identify congruent figures first, and their little note here is, I just talked about that. Make sure that lists the vertices of the figure in the correct order. So like I was saying before, that ABC was DEF, right? So they had to be, the first one had to be in the, so when we said ABC congruent to triangle DEF, right? This A and this D have to be the corresponding vertices, and B to E and C to F. Hopefully that makes sense. Okay, so let's get back to it. So we are looking at this, and we're trying to figure out which ones of these are congruent. So it tells us already, but just by looking at it, hopefully you see that this one, that this guy right here and this guy right here look the same. Okay, so these two are congruent. This is 2 on the bottom, 2 on the bottom, 2 here, and then this hypotenuse is going to therefore have to be the same. These two, these look the same. That's the same size. That's 1, 2, 3. That's 1, 2, 3. So these are the same. So what happened? Okay, so if we just look at M, it came down 1, 2, 3, 4, 5. It went down 5 and left 1. Okay, so let's see. Down 5. 1, 2, 3, 4, 5 and left 1. Down 1, 2, 3, 4, 5 and left 1. Down 1, 2, 3, 4, 5 and left 1. So this rigid motion was a translation. Okay. It didn't flip or rotate, it just came down 5, left 1. Okay? So that's what happened with these two right here. Now these are obviously, hopefully, a reflection. So a reflection, again, I could come in here and this angle corresponds to this angle. This angle corresponds to this angle, and this angle corresponds to this angle. There's 3, okay? So hopefully that makes sense. Moving on. Okay, so describe them. The figure is congruent to the blue figure. Describe a sequence of rigid motions between the figures. Okay, so it looks like, or it is, that this corresponds with this side right here. So how did we get there? Well, if we rotated this 90 degrees, we would end up with something like, I'm going to mess this up, but we would end up with something like, oh, I'm definitely going to mess this up, like this. Okay, my drawing is not my best skill. All right, so it rotated 90 degrees, and that is in the clockwise direction, and then it looks like it went up 1. Here, let me get my laser instead. 1, 2, 3, 4. So a rotation of 90 degrees and a translation up 4. Okay, now this one's just kind of fun to look at and think about, so try not to look below, but if we just look at this original, how can I make this original? You can use the buttons as shown to transform objects in a computer program. You can rotate objects 90 degrees in either direction and reflect objects in a horizontal or vertical line. How can you transform the emoji as shown below? So how can I make this look like this? Well, if I just rotate this guy 90 degrees, then it's going to look like this, but his tongue will be over here. Okay, so this guy's tongue's on the left, this guy's bottom, and this guy's tongue's on the top. So now what do? Well, now if I flip it this way across, now I have, well, this eye becomes this eye becomes this eye, and this, you still have the smiley face, but the tongue is now over here. So that's what this is showing us, that you rotated it 90 degrees counterclockwise, right? And then, let's see, counterclockwise? I think we rotated that, and I think that's supposed to say clockwise. That's not correct, because this would be a 270 degree counterclockwise. Nope, never mind. They're right, I'm wrong. So I'm going to let you think about that though. So which way did it move? It moved this way, which is counterclockwise, right? The clock goes tick-tock, tick-tock, tick-tock that way. So it would be 270 clockwise. It'd be 270 clockwise all the way around from here to here. But counterclockwise, it went just this way, and that's opposite of the tick-tock, right? Okay, and then this thing here is showing that it flips across the x-axis. So a flip across the y-axis is this one over here. So these are the buttons that you can use to play with it. Kind of fun. I think there's at least one of those problems on the homework, so enjoy. If you have questions, as always, let me know.